Both consciousness and quantum phenomena are subjective and indeterministic. Is this a coincidence, or there is profound reason behind this? We propose that consciousness is a quantum phenomena. It should be studied with quantum physics. We propose quantum theory of consciousness in this presentation. This work is done with Dr. Zhigang Sha. My name is Rulin Xu. My field of research is in quantum physics, string theory, and grand unification theory. So why do we need quantum physics to study consciousness? I have already mentioned the number 5 reason. The first reason is that quantum phenomena are the elementary, basic, and fundamental phenomena underlying all observed phenomena. Number 2, quantum physics studies physical, energetical, and the informative aspect of an object. The informative aspect is closely related to consciousness. Number 3, quantum physics studies stable structure, order, connection, correlation, and coherence, which is what leads to consciousness and life in general. Number 4, quantum physics studies the relationship between the wave and the particle nature of an object. To study the relation between brain waves, brain structure, and function, we need quantum physics. So this quantum theory of consciousness is based on a new interpretation of quantum physics. And this new interpretation in our previous work, we have shown it can address the quantum measurement problem and leads to relationship solution about relation between mind and body. So this new interpretation is based on 2 principles. The first principle is the basic ingredients of everything is the quantum vibrational field, which carries matter, energy, and information. Matter is what we see, hear, observe, measure, and experience. Energy is what moves and changes the matter. Information is what informs. It gives the form and shape to the energy and matter. So the second principle is that an object absorbs the quantum vibrations through resonance. The reception and processing of vibrations, including information, energy, and matter, leads to subjective conscious experience. So conscious experience occurs when one activates the body to receive quantum vibrations, information, energy, and matter. So in this theory, everything is a quantum vibrational field, mathematically described by the wave function. Wave function can tell us what are the possible energetic states and vibrations in the fields, and also the probability stay in at each of the states. So the probability gives us tells about the information aspect of the vibrational field. The matter is determined by the observer. It depends on what kind of vibrations the observer chooses to receive. For example, if the observer uses the eyes to receive the visible light, then the observer have experience of an image of visible light. If the observer chooses to use the ears to receive the sound, then observer have experience of the sound. So this theory of consciousness can address the mind-body problem. It basically tells us the body and mind are one. To solve the hard problem of consciousness, David Chalmers proposes 3 principles. And all of these 3 principles can be derived from this quantum theory of consciousness. So we conclude that this theory of consciousness can address the hard problem of consciousness. So it can also make predictions. One of the most important predictions is that there exists a universal vibrational field to which everything can access and from which everything can receive and emit vibrations. It can also explain why and how large-scale and almost instantaneous synchrony of brain waves can happen. not only between different parts of the brain, but also between the body and as well as with external objects. I'll give you one example. The Schumann resonance is a set of frequencies generated by the Earth's ionospheric cavity resonance. It is observed that there is similarity and even coherence between Schumann resonance with the brain waves such as alpha, beta, and gamma waves, brain waves. It's also noticed that the EEG rhythms tends to become synchronous with Schumann resonance activities. So this repeated resynchronization within the brain waves happens within very short time and covering very long distance. The dominant mechanism using classical physics through neural interactions by synaptic transmission or gap junction coupling cannot fully account for the precise coherence of global brainwave synchrony. Hunt and Schuller proposed general resonance theory to explain phenomena as such. However, the specific mechanism remain unknown in this series. According to quantum theory of consciousness, the similarity between Schumann resonance and some brain waves come from the ability of the brain to resonate with Schumann resonance. Through the resonance, it brings Schumann resonance inside the brain and establish coherence with the Schumann resonance. This can also lead to synchrony among different parts of the brain. Through this mechanism, coherence and synchronicity can also happen between different parts of the body, people, and different objects on the earth. And this has been observed in some experiments. So another prediction of this theory is that we should treat the brain's neural network as a quantum information system. So quantum information theory has developed very rapidly in the last few decades and has been applied in many areas. One of the biggest discovery is about the quantum entanglement and quantum entanglement entropy. So the idea is that it discovered that the interaction among neighboring units such as atoms, molecules, maybe neurons and cells, and can lead to the quantum entanglement. And this quantum entanglement can lead to long-range order and various phase transitions. It is discovered in the condensed matter physics that many of the new states are simply the patterns of many body entanglement. So the research in the formation of memory in the brain indicates that memory is basically the reactivation of a specific group of neurons formed from persistent firings that leads to change in the strength of connections between among these neurons. This interaction can establish quantum entanglement and coherence, which leads to special states or phase transition. So therefore, we can see that the memory is basically a quantum entanglement state from the viewpoint of the quantum information theory. So how can we protect the memory, the quantum entanglement? So in the quantum information theory, they developed the quantum error correcting codes to protect the system and its quantum information against noise and decoherence. So the main idea is to spread the 1 qubit quantum information onto a highly entangled state of several qubits. In this way, errors caused by decoherence from the environment can be corrected or reduced. So each neuron contains thousands and tens of thousands of synapses, which are connected through the same cell body. Therefore, they are in some way quantum entangled. So our brain has developed and is naturally using quantum error correction codes to protect memory. So we want to conclude this talk by saying that the quantum theory of consciousness is very needed, and it can address the hard problem of consciousness. It also provides the physics and the mathematical formulations to study neuroscience and consciousness. It can provide new insights and to solve some unsolved problems. So we welcome your comments and inputs and collaboration. Please feel free to connect with me, and I'm looking forward to talking with you.